So in this lecture number 4, we're going to be looking at the concept of matrix rank. Okay, so let's go ahead and run the codes. Now, the rank of a matrix is basically a single number, and it gives you an insight into sort of how much information is stored in that matrix. But what does that mean? So if you think of the columns of a matrix or the rows of a matrix, we have discussed this before. Would you be able to, are these columns independent linearly from each other? Or are the rows independent linearly from each other? That is ultimately what governs the matrix rank. So if you think about it, like your information in a matrix is going to be packed in either in your columns or in your rows. And if these rows or columns are not linearly dependent on each other, it means they are independent. As such, you can say that a matrix which has, let's say, three columns or three rows which are linearly independent, it has three packs of information. Okay, whereas if a matrix has three columns and two of the columns are linearly dependent on each other, then basically it has a lower rank because you can then say that only two of the columns technically bear information that is going to be useful. Okay, now don't mistake the rank of a matrix with its dimension. So you can have a matrix which is 1000 by 1000 columns and rows, and you can technically have a rank of one. You know, it is possible. So it has nothing to do with the dimension of the matrix. And you need to bear in mind the maximum possible rank of a matrix will be the minimum of the number of rows, yeah, or column numbers. Okay, so if you have a 3 by 2 matrix, okay, so 3 rows and 2 columns, the maximum rank you can get in there is going to be 2. Okay, all right, so you can think of if, I mean, like maybe you can say rank is the dimensionality of information, okay? But I, of course, as usual, expect you to be reading about these independently. And here we just trying to basically see how do we do this stuff with Python. So let's go ahead and make three matrices, okay? So we have matrix A, B, and C. And let's take a look. So matrix A, matrix B, matrix C. Okay. Um, well, let's see. I mean, like, are these, what's the rank of these matrices? I mean, of course, there is one way to do this by hand using reduced low echelon sort of application. But I'm assuming that you already know that or you're going to learn about it. But how would you do it in Python? Trying to find out. Now, the shapes, of course, they're all 3 by 3. Easily we can see it by eye. Now the function we're going to use is, let's say we want to look at C, yeah? So it's going to be np.linalg dot matrix rank, okay? And let's look at C, for example, here, okay? He has a rank of 1. What does that mean? Let's see. For example, I mean, of course, these are made so that you can sort of have a feel for it. Is there a way? I mean, but we have 1, 3, 2, 3, 9, 6, 5, 15, 10, and then the rows are 1, 3, 5, 3, 9, 15. Look at it. Both looking at rows and columns. Let's just look at the columns, for example. Can we get from matrix, from column 1 to column 2 in a linear sort of operation? What if we multiply column 1 by 3? You're going to get 3, 9, 6. So these two columns are linearly dependent. They are linearly dependent. How about column 1 and column 3? Well, it seems that if we multiply that by 5, the first column, we're going to get column 3. So all these three are linearly dependent with each other. As such, we get a rank of 1. Now, if I was to look at matrix A, it is 2, okay? Uh, how would this work? Okay. Um, I mean, like, it is not always possible to see this with the naked eye, of course, but then let's look at the rows this time. 1, 3, 5, 4, 1, 5, 2, 6, 10. Okay, so it seems that the row 1 and row 3, they have a dependency. But the middle one, the second row, seems to be independent. So technically, the first and the third are linearly dependent, while the second one is independent from them. So we are having a rank of 2 in this matrix. And if we look at matrix B, 3, okay? Basically, that indicates that either in the rows or columns, you cannot basically get one of the other columns or rows by doing anything linearly with either of the other rows or columns. Yeah. So that's what basically ranking means. And of course, we use the function from the lineage package of NumPy, matrix rank, matrix underlined rank, and you get the rank. So again, here I'm running the same operation, and which matrix has the highest? Of course, we have B, which has the highest rank here. Okay, now what happens if we add or multiply matrices together? How would this impact their rank? Okay, so we have matrix A, so we knew that matrix A had a rank of 2 and matrix B had a rank of 3. So if we add A and B together, as we're going to do now, what is going to be the rank of this matrix? Do you think it's going to be 3 or 2? So let's just run it. 3, okay? Um, well, it seems that by adding a matrix with a rank of 3 to a matrix with a rank of 2, you're getting the maximum rank out, okay? What about adding A and C? Now remember C was 1 and A was 2, yeah? So if we go and just show A and run that, we get a rank of 2, okay? So there seems to be a rule basically here, and the rule is that the rank of two matrices added together will be always less than or equal to the rank of A and the rank of B. Okay? Okay? So it's going to be either less than or equal to their associated rank. Okay? Um, it cannot be basically above. So you can't have more rank basically once you add these together. Now, what if we have a product? So a dot product of matrix A and B. Let's see. What is going to be the case? I'm going to just run it and we get in 2. Okay, so remember matrix A had a rank of 2 and matrix B had a rank of 3. Now, what about A and C? Okay, and again they rank. And the rule with regards to when you're doing dot product, multiplication of two matrices together, the rule is that your rank is going to be the minimum of the rank of either A or B. In this case, because A had the lower rank, okay? So the product of these two matrices would have a rank which is either equal to the minimum of either of these or less, okay? So now rank of a matrix, which is, you know, the product of a matrix with its own transpose, yeah? So let's look at that. This is the rule. So if you have a matrix A, yeah, its rank is going to be equal to the rank of A transpose A, or A transpose, or A A transpose product, basically. That's the general rule that follows this up. I'm just going to, visualize this. So matrix A, the rank is 2. A transpose, it's 2. A transpose A is 2. And A transpose is going to be 2. Okay, so this is it basically. So rank is very important, of course, and we just basically learned this in this lecture how we would use Python and NumPy basically to extract out the rank of a matrix. Okay, so I hope you have enjoyed this very short lecture, and I'll see you in the next one. Take care.